Hello, everyone, and welcome. My name is Nadia Guardini, and I'll be moderating today's webinar on the BLK360 SE Essentials solution. Today with me, we have Serena Persichelli and Marcus Matthias. I'm going to introduce better them afterwards. And about today, here's what to expect. So we'll begin with an overview of the BLK360 SE Essentials solution by Serena, and we will see together with her its components, main features, and workflow. And then we will have Marcus presenting a demo using real data to show the processing, preparation, and modeling in Pinpoint. And as a bonus, only for you today, we'll have you will have a sneak peek on the new version of Pinpoint, which will be available very soon. And finally, we will have a live Q&A session where our speakers will answer your questions. So before we dive into the BLK360 SE Essentials, let me quickly introduce myself. I've been with Leica Geosystems since 2018, and I've worked in reality capture for over 15 years across a wide range of industry. And today in my sales leadership role, I help teams and customers to adopt these technologies effectively, understanding their needs and guiding how solutions fit into their workflow across Europe and North America. And let me now introduce Serena. Our first presenter, Serena Persichelli, is product manager for the BLK360 and the BLK360 SE. She has over 7 years of experience in hardware and software product management at Leica Geosystems, and she holds as well a PhD in electronic engineering. And as an expert in reality capture technology and workflows, Serena will guide us through the BLK360 SE Essentials today. And then the second speaker for today's session is Marcus Matthias. He is CEO and co-founder of SCASA, the team behind Pinpoint. Marcus holds a PhD in computer vision and machine learning, and he focuses on product vision and bridging advanced technology with practical industry needs. So basically, Marcus is passionate about making complex technology practical and useful for professionals in their daily work, which is exactly what inspired the creation of Pinpoint. So before we start, a few quick guidelines for you today. The sessions from Serena and Marcus were pre-recorded for your convenience to ensure a smooth experience without any technical hiccups. And the video will be available after the webinar for you as well. But please stay with us until the end, as you will have the chance to talk live with our experts during the Q&A session and get your questions answered. So if you have any questions during the presentations, just submit them in the Q&A section, and we'll address them during the live sessions at the end of the webinar. Finally, just a quick disclosure and note to everyone. Today is not meant to be a training or a full tutorial, but it is an overview about the solutions. So if you'd like to have then more detailed guidance or information about the solutions, feel free to reach out afterwards. Now, let's take a moment to quickly highlight the main benefits of the BLK360 SE Essentials. So first of all, it lets you scan and review the data directly on site in near real time. So you stay in control of the capture process and can ensure high quality, complete data from the start. The second point is that it really saves time by streamlining workflows, and you can create 2D plans quickly with the scan to plan workflow, or generate fully detailed 3D model for more complex projects using the scan to 3D workflow as well. So in short, it offers flexibility for any project, helping to reduce errors and rework, which without this kind of technology might occur. And whether you need fast checks on site or detailed digital twins, the solution adapts to your needs. Now that we set the stage, we can watch the sessions from our product experts. We'll begin with Serena, who will introduce the BLK360 SE Essentials, followed by Marcus, who will demonstrate how it all comes together in Pinpoint. And again, remember that this will be a sneak peek in the new upcoming version of Pinpoint. So sit back and enjoy, and we'll catch up later again on our live Q&A session. Enjoy.
Today's webinar is about the Leica BLK360 SE Essentials, the essentials you need to scan, prepare, and model your work. So in today's presentation, I will go through the basic components of this package. In particular, I will give you some insight about the new BLK360 SE laser scanner, and also some introduction to the workflow and what you can achieve by using this package. As I said before, this is a comprehensive solution made of hardware and software, and the components of this package are basically three. First, the new Leica BLK360 SE imaging laser scanning. I say new because this scanner has been released only in May 2025, so it's pretty new to our portfolio. Then we have, as part of the package, the Leica Cyclone FIELD 360 app. And to finish, the Pinpoint registration and modeling software that you're going to deep dive into together with Marcus at the end of the presentation. So these three components are a very powerful tool from Leica Systems, and we will see during this presentation that will allow you for a full workflow from the field to the office. Now, a few words about the workflow. Everything starts from the field. And in the field, you will use your BLK360 SE imaging laser scanner. So a few words about this new product. It has a one-button operation. That means that you will be able to operate the scanner only by the touch of one button. You will be able to capture your point cloud with it, and the scanner will be synced all the time with the field app, the app Field 360. So your app is going to help you to remote control your scanner. What does it mean? You will not have to touch any button of the scanner, but you will be able to control it completely remotely. It will also help you to set everything regarding the settings of your scanning, from point cloud density to speed and to imaging. And it will help you to do pre-alignment of scans. What does it mean? That you don't have to worry too much in the office about registration of your scans, because the field app will already do a part of the job in the field by helping with a smart pre-alignment made on comparing of the point cloud to do that. And it means a lot of time saved in the office later. With the Field 360 app, you can also visualize your setups every time you capture one, so you can fix problems in case you see any, and you can have control of the situation during all the work. Finally, with the app, you can already in the field do measurement in 3D, add measurement anywhere in the space, and add also annotations or note into your scan data. Then once you finish the work in the field, you don't have to do any data transfer. When you go to the office, you can transfer anything that you want directly into the Pinpoint registration software. As I said before, there is a pre-alignment done in the field with the Field 360 app. That means in the office you can be quite fast, and you will see later. So you will start with the transferring of data. Keep in mind that the entire process is optimized in a way that every component of the package will work seamlessly together. So downloading your data from the BLK360 SE to Pinpoint is extremely easy. Then you will be able to start the work in the office, from editing to registering. And this will be the easy part, because you will see the software is extremely user-friendly. And at this point, you will be able to start working on your deliverables like 3D models, meshes, you can generate floor plans, orthophotos, and of course, you can export your data in multiple formats. But you will learn more about that later into when the presentation from Marcus will be live. Now, a few words about the new BLK360 SE laser scanner. So we call it BLK360 SE, where SE means standard edition, because we believe this scanner is the perfect combination between data quality, beautiful images, and accessibility. It is a laser scanner able to capture detailed, fully colorized 3D point clouds in less than a minute. So I will explain better what does it mean, less than a minute, later in the presentation. But what I'm able to say now is that this product is a beautiful combination of all the important functions that are very important for our users. And you will learn that during the course of this presentation. Let's look a little bit at the details of the new scanner, and let's start from the imaging system. So we know that our users love to have beautiful images, that beautiful images are very important for you. That's why we equipped the BLK360 SE with a camera system made of 4 cameras to collect LDR and HDR spherical panorama images. And when we are working with HDR, you will have access to 5 level exposures. So I know this is quite technical. To make it short, you will be able to produce beautiful images with this scanner in different lighting conditions, even in hard situations. Then regarding the laser scanner performances, it has a range of 45 meters. That means that you can scan with this instrument with a diameter of 90 meters, with a 3D point cloud accuracy of 4 millimeters. So we are able to achieve with this scanner a very good data quality and accuracy that for us is a very important factor, and at the same time achieving very good imaging, very good quality of your images. And all of that in a very compact design, because the scanner itself is only 15 centimeters high and weight less than 1 kilo. That means this scanner can go everywhere, can fit everywhere, and is the perfect choice for every type of project, even the challenging situations where you don't have a lot of space or you are working in difficult conditions. Now, a few more details about the settings that you can set on your laser scanner when you decide how you want to start a project. So we offer for the BLK360 SE 3 resolution settings. And these 3 settings are fast, dense, and dense plus. What does it mean? Of course, fast means that your point cloud would be less dense. And this translates in an important difference in terms of the time you need to perform a single scan. So if you opt for a fast scanning resolution, you will be able to scan your environment in just 28 seconds. So I can easily say that the BLK360 SE is one of the fastest scanners in the market. But then you have to also consider the time you need for collecting images. This will happen at the same time of the scanning if you select panorama images as an option. So it takes 8 seconds to collect an LDR image. HDR takes a little bit more, about 20 seconds. Keep in mind, those are indications because the duration of the capturing of panorama images can vary a little bit depending on the light conditions. But just to say that a typical, let's say, parameter setup, when I say typical, I mean that I see that very often between our customers that are working with 2D plans or for BIM applications. They usually choose a setup with a fast resolution setting and LDR. And with this setup, you will be able to scan and collect images in 36 seconds, more or less. That means way under 1 minute. This makes the scanner one of the fastest in the market. So To go a little bit more in details about, let's say, the power of this scanner and this solution, I would like to give you, let's say, a realistic example. So we scan an apartment. This is actually an office space of 114 square meters. And to do this exercise, we scanned 46 setups. We collected 46 setups. So this is already quite detailed. We decided to take 46 setups in order to capture a lot of details, and because there were a lot of monitors, but sometimes you can do less for such a square footage. But in order to do that, with the Fast Plus and LDR settings, as I was mentioning before, this is typical example. Overall, you will need 30 minutes to scan the entire apartment with 46 setups with BLK360 SE. So 30 minutes includes the time that the scanner will operate to scan the environment and take images, but will also include the typical time that you will need to move from one setup to another, to check that everything works in Field 360, to redo in case an error is made. So this is an average time that you will need to do this collection of data for an average user. And for a daily user, that could translate in hundreds of hours saved all over the course of 1 year, of the course of 1 month, compared to traditional methods. If you're working with a laser distance meter or with tape, sketching your measurements by hand, this translates into being able to accept more jobs, moving faster from one construction site to another, and in general, improving your customer base and your business. So adopting this solution really allows you to be faster, more efficient, not only on the field, but also in the office, as you will see later during Marcus' demo and presentation. Just a few words before I go to the conclusions about the Cyclone FIELD 360 app. Definitely, it would deserve more time, but to be sure today, I will just give you a few, let's say, important points about this very powerful tool from Leica Systems. The FIELD 360 app will help you to control, operate the BLK360 SE, and also change all the settings remotely. So all the settings we saw before, the density, the LDR, HDR settings, they all can be controlled just by the app. That is very user-friendly, has an extremely good user interface. So it will take you literally minutes to learn how to use this app. And the strength that this app is bringing to the workflow is that you will be able to align and register the scans automatically. The app will suggest, in case something is not ideal, how to fix that. That means that this is the perfect solution also for users that are new to scanning and are new to reality capture, because everything is kind of guided for you. And all the time you can visualize and verify capture data. That means that when you're on the field, you have full control and you will not have bad surprises when you go to the office. You will not find out that you missed some data because this is something that you can see directly on the field and redo in case you need. And of course, add measurements, annotation, and all the additional information you want directly on your scan data on your point cloud. In general, the app is available on Android and iOS. And yeah, again, it's a very important part of the workflow in terms of software, and I truly recommend you to try this on. So to conclude my part, Leica BLK360 SE Essentials is a combination of 3 very powerful tools from Leica Systems, the Leica BLK360 SE laser scanner, the FIELD 360 app, and the Pinpoint desktop software. And this whole solution has been designed with our customers in mind to help you to streamline your reality capture workflows and be more efficient and be faster in the field and in the office, and help you to model your world with reality capture. So I'm done. Thank you very much for your attention. Now I will hand over to Marcus, that will give you some insight on Pinpoint software and also give you a full demonstration. Thank you very much.
Thanks, Serena, for your introduction. And now my name is Markus Matthias, and I'd like to present to you Pinpoint and outline a typical workflow in the software. As you can see here, the software consists of two main modules, the Pinpoint registration tool on top and the Pinpoint modeler on the bottom. These tools have different purposes. So the registration tool, the main purpose here is to generate a 3D asset. This means registration, creating 3D data, performing cleanup, and in the end, creating a clean 3D point cloud or even a 3D mesh. On the other hand, the modeler tool, the main purpose is to extract information out of the 3D point cloud. This can be simple information like performing measurements, but it can also be complex information like projections or 2D floor plans, for example. So let me jump right into a live demo of the software. So this is a typical import, how it looks like in Pinpoint registration tool. So you connected your scanner, you imported your data. And as Serena already mentioned in the beginning, when you did already some pre-registration during your scan, then the data comes into the software already registered, and you can see immediately that it looks already quite nice. But of course, this is not always the case. So there might be different situations where you either did not perform registration in the field, or you could also have a situation like here, that you actually did a second scan, probably at a different point in time, or even with a different device. And then you might have a situation where you actually have two jobs that live in a different coordinate frame, but you can clearly see that these two jobs actually belong together. So now we will perform a registration. And for that, we will enter the mode of register scans. And as you can see here, at the moment, all scans are movable. I will only use the second job, which are the scans on the left, and set this movable. As you can see, everything that is set to move here will move together, and everything that does not have the move sign will stay stationary. So now you can move all these setups from job 2 together and overlay them with the first job. And in Pinpoint, you do a cloud-to-cloud registration. So you just have to roughly align the two jobs. And we will now use the functionality snap groups, because we want to have the entire group move together onto the other group. So the two groups are here, the two job files. So if I press register groups, you will see that the two jobs align with each other. And this is an iterative process, so it will always make a step. So it makes totally sense to hit this button several times and see if there is still some movement left. And you see now it's snapped again towards the right direction. And if I press it the third time, nothing more happens. So now we have these two parts together, and I'm generally happy with the initial solution. But what is always advised is to perform something which is called bundle adjustment. For that, I set all the scan positions to move. And now I will use the functionality snap scans. As soon as I hit this, it will allow the algorithm to move every scan individually. So every scan can move, and it tries to find the optimal solution between all the scans and move them towards each other. So after pressing the button once, I can look at the statistics. And here on top, you will see a development of the error. So there is some kind of error matrix about how good the registration is, and over time it goes down and it flattens. So as before, we press the button another time. It's an iterative process, and as soon as you don't have an error decay anymore, I would expect now something like a horizontal line. You see that the error is already fully minimized. Then you can actually stop the registration. And now I have to get some idea about how good is my registration actually. And it's always sorted in a way that the worst registration is listed on top. And you can see that the worst scan position is setup 21, and it has an average error of 2 millimeters and a maximum error of 5 millimeters. This is a very good registration. So from there on, I do not have to do further inspection about this model, because I'm already pretty sure that this registration is really good. And after doing so, you can actually exit the register scans folder, and I'm now happy about the alignment between each scan positions. From here, you can go even further and look at where do you want to place the whole model in the world. So this could be, for example, over geo coordinates, but it could also just mean that you want to set a origin at some point. For example, at the moment, you see that the coordinate frame is somewhere over there. And now I just want to put it into some corner and align it with the walls, so that I have a beautiful coordinate system for my later work in the modeler tool. And for that, I just have to sample points from different planes. And you see, as soon as I have points from 3 different planes, it will try to move the origin to a new position. And in the end, I also want to rotate the model that this axis nicely align with the walls. And I do it exactly the same. I just sampled some different positions. I hit OK, and now I have my coordinate frame nicely placed. So now I'm done with everything that is related to scan positions and the overall position of the scan in the world. So it has now a coordinate frame, and I'm happy with the relationship between each scan with each other. And the next very common step, if you look at the scan positions here, the person scanning was clearly interested on the interior of the building, but obviously the laser scanner doesn't care about this and also scans through the windows, the neighboring building. So this you can handle with a cleanup. I start a new cleanup, and I want to generate a focus area in the first step. So advised procedure is here to change to orthographic projection, because then I can have a nicely view on top of the building, and now use the lasso tool to just roughly walk around the building to actually cut away unneeded geometry around it. So I do it quite rough. I would change to the perspective view anymore, and you see that the building is now marked, but I of course want to remove the exterior of the building, and I can just hit the trash bin and it will be gone. And then I will just stay in the tool and do further little cleanups. You can also mark different things jointly. So I just put a few lassos, and at some point I might say, okay, I'm happy with that, and you can continue. So there's one very powerful cleanup tool that I want to show in a little bit more detail, which is the mirror tool. So this is a typical situation that you are inside the house, and there is some geometry floating in midair, as you can see here. And you can clearly see that this geometry does not exist. It's only one-sided scanned. And the mirror tool is very powerful to remove this kind of geometry. So you just have to hover over the geometry, and then you can figure out from which scan position this geometry has been scanned. And if you go out here a bit, you see that this type of geometry has been scanned from a scan position in a totally different room. If you go to the scan position, you immediately see that there was a mirror on the wall. And with the mirror tool, you can now define the wall plane, set it roughly to the plane of the wall, surround the mirror once, finish with double click. And now all the geometry that is generated through scan positions looking through these mirrors is marked at once. So if I look in the mirror tool again, I can see that, for example, this geometry that I have here is generated from one scan position. Here's another scan position and yet another scan position. So with a single operation, you can mark a lot of geometry, which is ghost geometry in the building, and delete it at once. Like this, you can continue until you get a very clear version of your building. You can also remove persons and so on. So now I'm at the position where I have my asset. It's also cleaned, and I can generate first deliverables out of this. So one deliverable is just the 3D point cloud. And if I go here to export scans, it will actually keep the scan structure as before. So it will have individual scans that I export, and I can just write them to standard formats, for example, E57, or to recap, also some ASCII formats, or you can also export the panoramic images that are captured by the device by itself. So this is one way of exporting. But when you go in the point cloud here, you see that it has like a bit mixed colors, and it doesn't look so nice yet. So we can generate a merged model with optimized colors, and this is a merged point cloud. So it does not have individual positions anymore, but has a sampling grid of the point cloud. And by doing so, you get a very high quality point cloud, which is also super compact. Let me show you the result of a merged model. And as you can see now, we have a very clean point cloud with very clean structures. And with the same functionality of the merged models, you can also generate, for example, a 3D mesh. And this is indeed a mesh. If I go very close here, you see that this is actually triangles and it's not a point cloud anymore. But you get this with the same pretty colors that we had before. And all of the assets that you generate, you can export at any time by just clicking on the disk symbol and export it to, for example, OBJ in this case. So now that we are done with generating the asset, we now want to extract information out of it. So we will move to the pinpoint tool, and this is a short export. And I will open the same model again in the pinpoint modeler. And while importing the data, it analyzes the 3D structure behind it, and it will cluster the 3D model into dominant planes. So as you can see here, there are different colors, and this is the normal view in which you start the modeler. At any time, you can switch back to the point cloud view. And just to clarify here, this is indeed a point cloud. If I change the size of the points, you see that these are actually not 3D points, but they are actually little disks. And these disks are orthogonal in the same direction as the underlying geometry. And if you change the size of this disk, you actually close up the geometry. And this is really important for a software like the modeler, because in other software, you have often the problem that you pick through a surface and you pick some points in the background because you just went in between of 2 points. And with disclosed surfaces, you do not have this problem. But anyway, we will work mostly in this view where you have the different colors. So what do they mean? The main functionality in Pinpoint is that it makes you really easy to pick a 3D point. So naturally, if you would want to pick a 3D point, you would just try to eyeball it and go to a specific position. In Pinpoint, you do it by intersecting planes. So when I go with my mouse pointer over the different planes, you see a grid highlighting the planes. And now in order to define this point, I just say, this point is the result of the intersection of this plane, and this plane. So rather than picking a point, I define it over constraints. And as you can see, the mouse is actually a sphere, the mouse pointer. And this sphere intersects all the points at once that it touches. So you just have to go to a certain point, it will touch 3 surfaces and intersect them at once. So with a single click, you can snap 2 corner points. And this is really helpful for most of the tools we use in Pinpoint. So let's start with a very simple first tool, which is just analyzing the point cloud and getting data out of it. For example, you want to perform a simple measurement. You just click on the points you want to measure and you get the distance. You can click on 2 planes and you can get the angle. At the same time, you can also select features from the 2D point cloud and say, for example, I want to have the orthogonal distance from this lamp to the floor, and you will get this distance. So just going back to the model, getting simple measurements is really straightforward in Pinpoint. And through the snapping that I explained before, it's also very fast. And before we go into the modeling, let me show you a few operations that you can do without performing any 3D modeling. For example, point projection. Here you select through point projection, and then it expects you to say a direction, which is a plane, and you define a starting plane, you confirm it, and an end plane. And now you get the option to, for example, generate orthophoto by projecting these points, or what we do here now is 2D point samples. And what it will do now, it will take the points in between the 2 defined planes and make this intersection. And this is indeed just a slice through the point cloud. If you go here very close, you will see that at some point you actually see the individual points that were projected to these planes. So as you can see, it's super simple to generate a first intersection. You could also do, for example, an orthophoto. I just go different direction. I select the floor. I say, okay, now I do not want to go it with the mouse, but type a number. I just in the lower right corner, I typed 1 meter, and you can see there's a plane 1 meter above ground, but I want to start 1 meter below ground. I just hit minus. This is my first plane, and my second plane is 1 meter above ground. And now I select, I want to do an orthophoto, and the reference plane is the floor plane, exactly between the 1 and -1 meter. And like that, you can also then generate orthophotos from different directions. Could be a facade, could be a floor. And in the background, it will create a point cloud and get the original point cloud data to get a very detailed orthophoto out of this. And yeah, so this you can get without doing any modeling, but of course the strength of the software is that you can actually perform 3D modeling. For that, I will just quickly show you how I would model this room. I use the function modeling add surface, and I would start with the floor. After clicking on the floor, I select this hand symbol, which means that I want to work on the floor plane now, and everything that I do in the following is related to the floor plan. I also hit this button, which means in order to define the outline of the floor, I just have to press on individual surfaces. So I just go once around and I press to every single wall that I see. And as you can see on the bottom, it will draw a green line indicating the outline of the room. In the end, you just close it and you have captured the floor. The nice thing now is, while doing so, as I said, it does intersecting planes. This point, for example, the software remembers that it was constructed by using the 3 planes. So if I now use extrude and I pull this plane upwards, the ledge here will exactly follow the corner from before, because we knew how the corner was defined. So with the simple operation, you already captured the base layout of the room. And now you can start to add, for example, smart elements like windows. You just click on it, drag and drop the window to the current position. And again, very fast, you can add window geometry. If we also want to add doors, for example, you can do the same process. We add just quickly the outside surface, surrounded ones, and then add an element, which is the door. And here I usually take two walls. So the first wall, the second wall, I get my door element. I can drag it around. Now I see it's a little bit slanted here. I can just correct that. And in the background, you will also see the opening of the door. Will it open to the left or the right? So this was already correct. I press OK. And the same way as we entered the windows, you can also add a door element, for example. And this way, very fast, you can actually go to a 3D model of this entire office. And this, even though the geometry is quite complex, it will take you around 15 minutes if you are trained in Pinpoint. And in these 15 minutes, you can capture the entire basic geometry of this model. Let me also show you how you would do stairs, for example. They would just outline the stairs, go to the most, let's say, extreme points of the stairs. And you finish this polygon. And after that, you can just click on it, say this is, I expect that this is steps, and you click on a few, and then it will estimate the rise and the depth of each step, and you will have a 3D model of the stairs. Okay, as you can see, we can capture the geometry, and probably one more aspect of it is you can also rate how good you've done, because a lot of people ask, so how do I know how well this capturing was actually done? For that, we have the functionality visualize error, and I can tell them to visualize the distance to the point cloud. And for example, I say if it's 2 centimeters distance, it will be red. If it's 2 centimeters below it, it will be blue. And then you just hit compute, and it will show you an error mesh. And this will point out the strength of Pinpoint. So of course, where you have some geometry standing, you cannot see much. But for example, if I would have picked the corner here, you see that this corner is actually sticking out. It's red. And the corner is much better defined over the intersection of plane. So probably someone, when the corner was painted, there was like a big chunk of paint pressed into the corner, and so picking the corner is actually not the best idea. And from here you can now see that sometimes the roof is hanging through, which is quite common with these roof structures. And now it's up to the modeler to react to this situation or just take it as it is. Okay, so now we want to move towards floor plans. So we go back to our already modeled building. And the easiest way to do a floor plan, you actually do not have to do all the extrusions. You can just say, I want to have a surface projection, and you select which surfaces you want to include in this projection. And I will just do it quickly. And you will get already an outline with the different surfaces. And this is, in fact, not points anymore, but line segments. So you already get the different rooms. You have the square meters numbers of the different rooms. You have the measurements of the rooms. This asset you can then export, for example, in DXF. But Pinpoint goes a lot further than that. As you have the complete geometry, you can actually generate a floor plan that is really complete. So I hit generate floor plan. The only thing that is missing now, I need to give every room a label for the floor plan later. So this has the label hallway, this has the label workshop, kitchen, and so on. So every room needs a label. And then you can just select the different rooms you want to include in your floor plan. Then you select if there are any steps in it. And then you have to define relative to which plane you want to define the floor plan, which is in this case just the floor plan, the floor plane or the Z-axis. And now it will do actually projections in different heights and calculate a proper floor plan with living area and floor area. So let me quickly configure the rooms. So I just say I want to see the floor area and the living area. And I disable the warnings for now. And you can adjust the labels a little bit where you want to have them. You can say which lines you actually want to show. And as you can see, for example, in the kitchen, the room we modeled in the beginning, the living area is quite a bit smaller than the floor area. This is because it's at the moment set to Germany, so everything below 1 meter is not considered as a living space. And everywhere where you had the slanted surfaces, it also has a special calculation on how much living space is actually counted for that. In this way, you can generate a full floor plan of this entire room. And we also have some beautification built in. This came from user feedback. They wanted to have the floor plan a bit more parallel and right angles rather than having a 89 dot something degree angle. And this beautification will just make everything a bit straighter. But keep in mind, all the measurements you perform are still done on the original 3D data that you feed into the algorithm. Yes, and with this is a few deliverables that I've shown, like different projections, different outlines that you can generate, and also the floor plan. And for now, I will end with this. But yeah, as you can see, all the results that you generate in between are saved on the left, and you can save all the results in the in exchangeable formats like SVG, DXF. Also, you can generate an Excel table, for example, from a floor plan where it will just list the different rooms with the square meters. Yeah, and this concludes my wrap up of the software, and I'm handing back to Nadia.
Thank you, Marcus. Now, welcome back to everyone, and I'll say we can have Serena and Marcus joining us again live for the Q&A session. Thank you very much to both of you. It is always for me super interesting, even if I know already the topics. It's always a different story when you hear them from the experts. So I'll go, if it's all right with you, I'll go straight to the questions that we received. So the first question, Serena, is for you. And we have an attendee asking, what are the main differences between the BLK360 and the BLK360 SE model?
Yeah, I can answer that. BLK360, with respect to BLK360 SE, has some additional functionalities. For example, BLK360 has an additional sensor that is called VIS, that stands for Visual Inertial System, that gives you an extra hand when you need to align and register your scans. And the BLK360, in addition to the BLK360 SE, has another, let's say, density settings that is called Fast Plus, that makes scanning with the BLK360 faster than with the BLK360 SE. So overall, 360 is faster than BLK360 SE, to put it this way. So we recommend to use the BLK360 for all those projects where you require a lot of speed, while the BLK360 SE is a great alternative in case you don't request these capabilities out of your scanner.
Okay, thank you very much, Serena. And the second question is also for you, about a clarification on the accuracy. So a confirmation that the accuracy of the BLK360 SE was 4 mm at 10 meters.
Yes, correct, 4 mm at 10 meters. And since someone asked before, both scanners, BLK360 and BLK360 SE, have the same accuracy of the 3D measurement.
Okay, thanks. And then we have a few questions for Marcus as well. The first one is about different surfaces with different characteristics and what to expect when you have, I guess, I try to interpret what it's in the question, but when you have different roughness and smoothness on the surfaces, if there is anything to consider for modeling in those situations.
Yes, so during import, you have some settings where you can actually set the sensitivity of the plane detection algorithm. So if you set it to really sensible, the 3D model falls into a lot more planes, which at some point will fall into the noise level of the sensor itself. So if you go below 5 millimeters or below 3 millimeters, then you really get a lot of planes. And if you need that kind of detail, you can always do that and fit regression planes later and pinpoint into the data. So you have always the chance to go very detailed and then work with additional regression planes from the data. But often it's also up to the designer or to the modeler. For example, we had cases where you had these metal walls that are like indented. So where's the center of this wall? Is it the front side or the rear side, or do you want to fit the plane into the center? So with regression planes, you can easily then define, for example, the center plane as your geometry. So you can work with different roughness settings.
Okay, thanks. So it's about having a clear idea of what you need in terms of expectations and results requested, and then you can find the best workflow to work around your need.
Yeah, so the standard settings in the import, in our experience, work pretty well. But yeah, if you know already that you are working on a specific example, you can adjust the settings, of course.
Okay, thanks. Then there is another question about cleaning the scans. So we are receiving a lot of questions, so apologies to all the attendees. I need to read them through them, and I'm going in sequential order. So this might take a while, and also don't worry if we don't get to answer to all of them. We'll follow up, but I'm doing my best to going through all of them and don't leave anyone out. So the next question was about, also for Marcus, about cleaning the scans and removing furniture in a similar way of unwanted or other unwanted scan points.
Yes, we have quite a few different tools how you can select objects, and one of them is the silhouette tool, where you can actually kind of pull up a silhouette around a person or around furniture and then quickly delete it. And there are also more like painting tools that you can use for selecting geometry, which will also work.
Okay, thanks. And then I see there is a question which is actually repeated by a few users about working on heritage buildings and how to manage situation where you don't have straight walls or floors. So for this, from a general perspective, from our experience, then it is a little different depending on the country, because we know that every country's have their own regulations in terms of what is typically required when it comes to built heritage. But overall, as you might have noticed, Pinpoint works, the modeling features that Marcus was showing works by planes, but it also has many different workflows when it comes to use point projections, and then going into more of a traditional kind of workflows when we can really leverage all the details coming from the point cloud. And so what it is usually recommended is to leverage like the tools that are working and that are designed for working on straight and flat surfaces, use those tools for those situations, and then instead leverage the other workflows available for more, let's say, complex or particular situations. There is a question for Serena about lighting conditions in the space, if they could be challenging for the scanner or not.
Yes, so as I was mentioning during the presentation, you can capture HDR images. That means this will help you a lot in case you have difficult light situation or dark scenes. Consider that most of our customers work on construction sites that are typically very dark or don't have a very good lighting situation. And that's why we design our imaging the way it is. So you can basically perform a scan and have a very good data quality in every lighting situation, even when it's dark. We also have customers working during night, for example, for renovation or constructions of the streets during dark nights. So I would say in any situation, you will have good data with the BLK360 SE. No problem here.
Thanks, and I'm glad you mentioned the example of outdoor constructions at night, because we have another attendee who is asking about working on outdoor scene to capture, for example, traffic accident scenes. So just a confirmation that that could work as well.
Yeah, we also have many customers in public safety and especially monitoring and documenting accident scenes. And let's say the benefit of using a laser scanning for capturing and documenting traffic accidents is the fact that the operator could stay far away from the street, far away from the scene, because only the scanner needs to be close to the scene, so at the center of the street, the center of the traffic, let's say. And the scanner can be operated from the side because of the connection with the remote connection with the tablet through Field 360 app. So it's also very safe to operate a laser scanner because of the remote connection. So definitely we have a lot of customers working with this kind of applications.
Okay, thanks. And also, as you mentioned again, there was another question about compatibility with Cyclone FIELD 360. Yes, so the BLK360 SE operates with Leica Cyclone FIELD 360 as part of the solution.
Yes.
Okay, how much do we have left? So someone is asking for the possibility of having a trial of Pinpoint. Yes, that is available. We'll follow up on that to give you access to a trial of the software. Another user is asking about export of the model for Revit. So, and there were a couple of users actually asking about Revit and IFC export. So I'll go, then Marcus jump in and correct me if I'm wrong. But so the kind of modeling the Pinpoint is empowering is working by surfaces, while, as you might know, if you're familiar with Revit, the BIM concept is a little different, meaning that every object has an identity, like floor, walls, doors, and not only surfaces. So what we would recommend, then depending on the BIM software that you're using, there are certain situations where BIM's platform do not receive well point clouds, then an option could be to export the model from Pinpoint as an OBJ and open it in the BIM platform that you're using and use that like as a reference to rebuild the BIM around that. Or what we would recommend in a situation like Revit probably is to export from Pinpoint registration tool directly the RCP file format, which is the compatible version for Autodesk products, and open the point cloud into Revit directly. So that way the workflow will be streamlined. Marcus, do you want to add something on this?
Yeah. Generally, we try to make all the assets in Pinpoint available in standard formats, which are widely compatible in different software suites. So you will always find some kind of open format that will be available in different software. So at any point, you can actually jump out and then move to the other software, as Nadia explained.
Good. So I think we are almost at the end of our webinar today. So as we do not want to overrun and to steal more of your time, I just take the occasion to remind that yes, Pinpoint is available for trial, and it is available then on a subscription base if you're interested in purchasing. And again, we will follow up with all of you after the webinar to make sure that all the questions that were unanswered will be. So again, thank you very much. It's really great to have been here with you and seeing all this participation from the audience as well. Thank you so much, Serena and Marcus, for the great insights today.
Thank you,
Nadia. Thank
and
you,
again,
everyone.
Thanks.
Bye-bye.
And the webinar recording will be shared with all of you as well. Thanks, everyone. Have a great night and take care. Bye.
Bye.
Bye.